So we're continuing to look at graphing polar equations. We started graphing these, and there is in front of us a couple of different types of polar equations and their different shapes. And with them are the equations that you can see the general form of what they may look like and the shapes that you'll get. So these are all things that we've talked about. We looked at graphing. R equals A sine theta and R equals A cosine theta. We saw that last week, if it was a cosine theta, it was a circle. And it was a circle depending on if A was greater than 0, you're going to get the picture that we have here above. If it was A was less than 0 and it was a cosine graph, we got that it was just a reflection across that, what looks like the y-axis. So we would have gotten something that, let's make a different color. So if A was less than 0, then we would have gotten something that looked like this, and it was a cosine graph. Same sort of idea for sine. Sine, remember, if we were looking at it on the unit circle, is our y value. So there, think of it, if A was positive, it was above, like the x-axis, or pole in this case. And if A was less than 0, it was below. Okay. Then we looked at cardioids. And so cardioids, when you're looking at these, we're looking at the coefficient. We're going to have some value A plus or minus B cosine theta, or A plus or minus B sine theta. When they're talking about this A is greater than 0 and B is greater than 0, we're not, at least for in front of the B, we're not looking at the sign in front. So plus or minus, you're just ignoring that. And so if you divide A divided by B and you get 1, then we know it's a cardioid. And depending on if it was a cosine theta, it's going to be with the x-axis. If it was a sine theta, it's with the y-axis. Okay, so continuing on, you have a one loop, depending if you divide those two together, and your values between 1 and 2, it's going to be a limicon that does not have an inner loop. And then if A plus B, where A is less than B, then we're going to have a limicon with an inner loop. So sometimes when you have your formula and you look at these, just to kind of give your a case or an idea of what shape you should be getting is really helpful. The other shapes that you could get would be a lemniscate. And that's if you have r squared equals a squared cosine 2 theta, or r squared equals a squared sine 2 theta. A can't be 0. We looked at roses. If we had A equals cosine n theta, or A equals sine n theta, and n was even, then it doubled the number of petals we had on that rose. Where if n was odd, that was the number of petals you had on that rose. And then we have an Archimedes, or I'm not sure if I'm pronouncing these names correctly, but we have this Archimedes spiral if r is equal to theta or theta is greater than or equal to 0. So let's pull some examples and let's graph those and recall how we were looking at those graphs last week. So in front of us, we have r is equal to 4 plus 2 sine theta. And so we want to graph this. So we talked about graphing these last week by graphing our equation in the xy plane and then converting it, using that to help us graph this. And so let's recall that looking at our equation, if it helps you, you can write it like this: 4 plus 2 sine of x. Our amplitude of this sine function on the xy plane is equal to 2. Our period is 2 pi. And we have a vertical shift up 2 units. up 4 units. So let's just get a graph of that really quickly. So we're going to get our important points. So we have 0, we have pi halves, we have pi, we have 3 pi halves, and we have 2 pi. If we were not doing a vertical shift, where max is 2, our min is -2. But if we're shifting up 4 units, our max was 2, and we're going up 4 units, we now know our max is 6. If our min was -2 and we shifted up 4 units, I know my min is 2. And we have a midway line at 4. And so now looking at our graph, it's a sine. So normally we start at the origin and then start increasing. And same sort of idea here, except that we're going to be starting at our midway line of 4. We're going to increase until we get pi halves. We're going to hit pi, down to 3 pi halves, and back up to 2 pi. We may need more than one period to get the graph of our polar equation. Okay, so now let's graph this on the polar equation. Okay, so our first point we know is at 0 degrees, and we know that R is 4. So 0 degrees, I'm going to be on my pole, and I know my R value is 4. So I'm going to go out 4 units. Then I know that I am increasing up until I get to pi halves. So I know pi halves is like my y-axis, and I'm increasing there until I get to pi halves, and I'm going to reach a max of 6. So I'm going to take this point and I'm going to increase till I get to pi halves. I'm going to get a 6. So I'm going to go up 6 units from here. Okay, so I'm going to increase here until I get to 6. And then from pi halves, where I'm at 6, I'm going down to pi, and I'm going to hit a mark of 4. So going to pi, I'm going to go out 4 spots. I'm decreasing until I get to 4. It should be symmetrical across that. Then as I'm going down to 3 pi halves, angle is 3 pi halves, I'm going to hit a minimum value, which is 2. So I'm going to come down and I'm going to hit a minimum value of 2. And then as I am increasing to 2 pi, I'm going to go back up to 4. So here is our image of our graph in polar form. And so let's just check that by pulling up a graphing feature on Desmos, and let's plot that there. So looking at our graph in Desmos, we have this picture here that looks like it's kind of like a circle, but it's flattened more right in here. And so my graph was a little off. I should have had more of a flattened area there than a curvature. So looking at the next example, we have r is equal to 4 sine 5 theta. Looking back at the different types of graphs that you can get in the shapes, this looks like it's a rose. Our argument, we have 5 theta, 5 is odd, and so it's going to have 5 petals. Let's first look at graphing this maybe on the XY axis. I know this is a sine graph again. I know that my amplitude is 4 again. My period has changed because my argument has changed. It's not just theta. And so recall we looked at sandwiching it in between a normal period, 0 and 2 pi, and solving for theta there. If I divided both sides by 5, my inequality are all 3 sides, I get 0 is less than theta is less than 2 pi over 5. So I know the length of my period is 2 pi fifths. So this is where we're going to want to break it down. We have 0 here. We know we have 2 pi fifths here. I might have some reflections across things. So maybe I need right here. Let's look at half of that size from 0 to 2 pi fifths. That gives us pi fifths. And the halfway mark between 0 and pi fifths is pi over 10. And the halfway mark between pi fifths and 2 pi fifths, remember we added them and divided by 2 or multiplied by 1/2. That's going to give us 3 pi tenths. Okay, so finding our important points. And then we know, again, amplitude is 2 and -2. I'm sorry, amplitude is not 2 and -2. Amplitude is 4, but our max is going to be 4 and -4. So because it's sine, we start on a midway line. We start at 0, and then we increase. We hit 4. We come back down to pi fifths. We hit our min and back up. Okay, so using this, and we might need more of that graph to help us get the whole thing. We're going to use this to help us graph this. Okay, so starting at the pole, we're at 0, 0. Then I'm going 2 pi tenths, and I'm hitting a mark of 4. So pi tenths, I'm not going to be very far. Let's just kind of estimate. So pi tenths, I'm going out 4 units. And I'm hitting a spot right here. Then at pi fifths, I'm going to be sweeping over to pi fifths, but I'm decreasing down to 0. So I get one of my petals from there. I'm definitely going to need more. This is only getting me one of my petals. So I'm going to need more of my graph. So from pi fifths to 3 pi tenths. So going to 3 pi tenths. I'm going negative. So since that's negative, that's a reflection across the pole. And I'm going to 4. So down here, I'm going to 4. So I would be increasing until I hit that. So we're going to get this shape right in here. And then at 2 pi fifths, we're still negative. So again, it's reflection. R is reflection across the pole when it's negative. So we're going to get this shape in here. So they should be about the same lengths. And so we know we need 5 petals. So this is not enough to see what we're looking like. And so we're going to need to have more than 1 period in here. Okay, so we need to extend this out. This is 5/10. This is 2 pi/10. Let's not reduce it. 3 pi/10. This is 4 pi/10. So I know I have a 5 pi/10, 6 pi/10, 7 pi/10. So let's keep doing that. So 5 pi/10, we're going to hit our max. 6 pi/10 will come back to our midway line. 7 pi/10 will hit our min. And then 8 pi/10 will come back up to our midway line. Let's see if I could grab this and move it. There we go. So doing this, continuing with our shape of our graph can help us. So again, so now we're looking at going from 4 pi/10 to 5 pi/10. So looking at 5 pi/10, so that's going to be basically a diagonal. We're going to go up to 4. And we're going to have something that looks like this. And then we're going to be decreasing, but we're still positive, so we're still staying there. And then at 6 pi/10, we're hitting this point right in here. So all my petals should be the same size. This is where having the paper would have helped me. 6 pi/10, I'm negative, so I'm going to be a reflection across. So I would figure out where 6 pi/10 was a reflection across. And we're decreasing. We're going to get back up in here for 7 pi/10. Looks like we just need 1 more petal. And so if we went from 8 pi/10 to 9 pi/10, we are increasing. And then at 10 pi/10, which is pi, we're back down to 0. So it looks like I'm a little off just because of my because of my angles. But this is going to come up kind of straight up, or up to the straight mark, and then come back down. not very pretty. Again, if I had had the graphing paper, it could have looked a little nicer, but let's go bring that to Desmos and graph what we just had. So pulling up Desmos, my graph is a little skewed. You can kind of shift it and we would have that picture. And again, I was saying that if I'd had graphing paper, that would probably been easier and I might have gotten a better, more accurate picture when I graph that. But in general, I just want you in this class to know the general shapes and to be get an idea of what's going on. And if it was on an exam, I probably wouldn't give you so many petals to do. And you probably would have more angles that you were more familiar with.